Hey everyone, welcome. Today we're diving deep into an incredibly fascinating 14-part field guide. We're going to demystify exactly how autonomous, production-grade AI agents are actually built and governed. If you've ever wondered how we get from a simple chatbot all the way to an autonomous system writing entire code bases, this explainer is exactly for you.
All right, here's our roadmap for today's explainer. 1. The agent architecture explained. 2. Anatomy of a harness. 3. The cybernetic steering loop. 4. Evidence from the field. 5. Frameworks, runtimes, and harnesses. And finally, 6. Building and future problems. Let's get right into it.
Section 1. The agent architecture explained. The engine and the chassis. So to bridge that massive gap between, a simple text-in, text-out chatbot and a robust system that can literally ship a million lines of production code, we have to look at one super simple equation. Agent equals model plus harness. Think of it like a car. If the model is a raw intelligence, the engine, well, the harness is literally everything else. It's the chassis, the steering wheel, the brakes. It's the software scaffolding wrapped around that language model that takes it from a stateless text engine and turns it into a stateful, goal-directed worker. And honestly, this makes total sense when you look at the inherent limitations of just a naked model, right? Out of the box, it can't maintain durable state, it definitely can't execute code, and it doesn't know anything beyond its training data. But by building a harness, shipping a file system, adding a secure sandbox, plugging in live tools, boom, we instantly solve those fundamental limitations. Moving on to Section 2, Anatomy of a Harness, the 8 components. Looking at how this whole thing is structured, it's just fascinating to see the foundational primitives working from the model outward. You've got these layers, right? Like the system prompt, the tools, the skills, and highly critical components like the file system, which acts as the ultimate collaboration surface for the agent. Now, the source document actually details 8 different components. We don't have time to cover all the specifics today, but you absolutely must get these 3 right. First, a file system. You need to give the agent a durable workspace. Second, a sandbox. This is so the agent doesn't, accidentally nuke the host machine while it's executing code. And third, context management. You have got to fight context rot. You do this by using techniques like compaction to summarize old history and progressive disclosure. This way, the model's reasoning doesn't just completely degrade as the task drags on. All right, Section 3, the cybernetic steering loop, Fowler's model. So now that we know the parts, how do we actually control the thing? Well, you absolutely need both of these mechanisms to make an agent reliable. Guides are your feed-forward controls. They anticipate behavior and steer the agent before it acts. Think of it like giving it strict coding conventions up front. Sensors, on the other hand, are feedback controls. They observe what the agent did and let it self-correct, like running a test suite. A feedback-only setup, that just gives you an agent that repeats the exact same mistakes forever. But a feed-forward-only setup gives you an agent that encodes rules but never actually discovers if they worked in practice. If you want to audit your own setup, this 2x2 matrix is a fantastic tool. It basically maps out your execution types. On one axis, you have fast, deterministic computational checks, like linters. And on the other, you have slower, semantic inferential checks, like having an AI review the code. The real trick here is balancing these across your agent's entire workflow. And here is a golden rule to remember. The best sensors coach, they don't just complain. Seriously, a dumb error message just wastes a turn. If a linter simply says error on line 3, the agent has to guess the fix. But an LLM-optimized error message that actually teaches the fix in context, wow, that becomes a powerful training moment right inside the run. It's almost like a positive kind of prompt injection. Which brings us to Section 4. Evidence from the field. OpenAI, Anthropic, and LangChain. That number right there is 1 million. A small team at OpenAI shipped roughly 1 million lines of production code with zero human-written lines. How on earth did they do that? By relying on a rigorously enforced harness. They proved that if you design the right environments, the right feedback loops, and solid control systems, you can actually scale your team's throughput linearly, literally just by adding more agents. Over at Anthropic, they ran into a slightly different issue. Their long-running agents would often declare victory way too early and just leave a project half-finished. So they solved this by mimicking a human shift handoff. They split the work up. First, an initializer agent maps out a durable JSON list of features. Then, a separate coding agent wakes up, reads the progress, picks just one single feature, and self-verifies it in a browser before moving on to the next.
And listen, this scaffolding is literally worth leaderboard positions. Just look at LangChain. They moved their coding agent all the way into the top 5 on the Terminal Bench 2.0 leaderboard purely by changing the harness. That's the whole secret. Two teams can run the exact same underlying model, but the one with the better scaffolding is going to win, hands down.
Okay, Section 5, Frameworks, Runtimes, and Harnesses, clarifying the stack. To cut through all the confusing terminology floating around out there, it really helps to read the stack from the bottom up. At the base, you've got low-level execution runtimes like LangGraph, which handle the infrastructure and persistence. Sitting right above that, architectural frameworks like LangChain give you mental models and abstractions. And finally, at the very top, sit highly opinionated batteries-included agent harnesses like deep agents. To put it simply, a true harness enforces an environment. Let's say a library refuses to let you remove its core file system and sub-agent middleware because it considers them absolutely required scaffolding. Well, it's deliberately constraining the system to ensure reliability, and that is exactly what makes it a harness, not just a framework. Finally, Section 6, Building and Future Problems, the Practitioner's Blueprint. So, when you're setting up your own architecture, the order matters immensely. Step 1, establish the durable workspace first with a file system. Step 2, secure it in an isolated sandbox with pre-installed runtimes. And Step 3, give it the freedom of a bash or code execution tool. Actually, scratch that. Give it a general purpose execution tool that always beats a fixed menu of rigid options. Now here is a classic anti-pattern you absolutely want to avoid: shoving all your instructions into a giant encyclopedic agents MD file. It just eats up your context window and completely crowds out the actual task. The fix? Ship a lean table of contents. Think of it as a map that points the agent exactly where it needs to look within a structured documentation tree. But hey, we have to be honest here. While we've solved how code is structurally written, we still face some massive open problems in the industry. The biggest one, the behavior harness. We can mechanically enforce architectural coherence, sure, but how do we structurally validate that an agent actually built the specific feature the user wanted? Managing contradictory sensors at scale, or figuring out if one master agent beats multiple specialized agents, these are huge challenges we are still actively working through. Which brings us to a provocative final thought. It's a question I hear all the time. As raw model intelligence scales up, as these models get smarter and smarter out of the box, won't all this scaffolding just become completely obsolete? Well, the answer is pretty nuanced. While models will certainly internalize some basic planning and verification, engineering the system around that intelligence, that's never going to disappear. Just like prompt engineering moved up the stack, harness engineering will adapt. Raw power will always need a system to channel it into useful work. The intelligence is in the model, for sure, but the leverage, the real engineering, lives in the harness. Thanks for joining me on this explainer today.